All right, hello everyone. Welcome to chapter 1 of our textbook for business decision analysis. So how these videos are going to work going forward is that we're going to have one video about lecture material. This is going to be your theoretical stuff from the book, stuff you'll need to know for your weekly quiz. And then I'm going to record a separate video which goes over some of the practice problems or some of the guided practice in Excel so that you can work on your problem sets. Now, in chapter 1, we do not have a problem set. We're just kind of laying the foundation of analytics as it pertains to the business world. And so this video will probably go a little longer than most of the lectures, whereas the remaining ones, since we're going to have 2 videos, I'll cut it a little shorter. But considering this week or in this module, we just have the chapter quiz to do, we're going to go ahead and take our time. Feel free to watch it at 1.5 speed if you like to get through it faster though. So we are in the second edition of the book. Some of the information in this on these slides is a little outdated, and for that reason, this will probably be one of the last few semesters we use this second edition, just because the analytics job market is so much bigger than it was even 7 years ago when this book was written. So I want to make sure you guys are getting the most up-to-date information on that. And let's go ahead and get started. So there are 3 reasons why analytics has exploded so much in the last decade and a half. The first one is technology, right? We can collect much more data than we could before. We're getting it through everyone's social media posts, right? We're getting it through everything you search online. We're getting it through RFIDs. We're getting it when you go and give your zip code at a grocery store. So we're collecting all this data, and so businesses have the data available to them. They pay whatever the amount it is they pay for it, and it allows them to better understand their customers, make the correct pricing decisions, and just generally get a better advantage in the industry that they're in, if they can do things more efficiently than their competitors can. So just we have the ability to get more data, and so the idea that we would use it goes up, right? The second reason is we've just got better methodology. We have figured out better algorithms to optimize it. We have come up with better simulation models than we have in the past, and we're just better at it. So the methodology has improved as the technology got there, and so necessity is the mother of invention. We needed a way to deal with all this data and to use it more effectively and to gain an edge, and so we did, right? That's what humankind tends to do is rise to that, rise to needs like that, right? And then the last reason is the computing power has kind of risen along with the methodology. We have cloud computing is a big reason. The ability to get information from these data warehouses to wherever at lightning quick speeds because of we have higher bandwidths than we did in the past. I mean, sure, businesses had like a T1 T1 modems and all that 15 years ago, but they were not as common to have that kind of computing power. People can work from home with gigabit speeds now in places, and that's why you see these tech booms in places that have Google Fiber and other fiber internet. 10 years ago, when Google Fiber was announcing what city they'd be in, you'd see a tech boom in that city, Kansas City, Austin, for example. So the reason that it's a one for one. We got better at these methods, and then we had the capabilities kind of rise technologically speaking along with it. So here's some trends from about a 10-year period from 2006 to 2015, just the total percentage of all job postings on Indeed.com, and that's about doubled since then. So it's gone from less than 0.5 to about 1.5. A lot of analysts were wanted during the housing bubble crash after 2008. That's why there was that spike right there. And then we went back to normal again, and then slowly have risen back up. But you can see the amount of jobs that are being posted. This is a good industry. It's a hot industry. It's one of the hottest industries as far as being able to get into a well-paying or good-paying job right away with right out of college, or being headhunted while you're still in college. When I was pursuing my business analytics degree and put that on LinkedIn, I was getting job offers before I had even graduated, because people saw that I was pursuing that degree. Job salaries. So this was as of last year. The median salary for a data analyst, 74,000. But if you look at the entry level, an entry level position in this industry at 53,000, that's really high for an entry level position. Maybe that's not a great salary with the recent inflation and all that. In Tulsa, you probably get by still. Some places maybe not, but it goes up quite a bit after that. You're looking at a median of 74,000, but once you're there for a little while, you get into a data scientist role. You're looking at well above the 100,000 range in a lot of places. So, and then if you get into management, you get into like a chief information officer role if you're in the business intelligence team. There's money to be made, and more importantly than there's money to be made, there's plenty of jobs out there, right? So it's not just that there's one job in Texas that pays us well, right? There's hundreds of jobs in Oklahoma that pay well. So it's a good industry to try to get into, whether it's data analyst, business analyst, sales analyst, etc. Okay, so change gears. Let's talk about decision making. If you are a manager, you've got to make decisions. You've got to make decisions all day as to what to do. Those decisions fall into one of three categories: either strategic, tactical, or operations. Easiest way to think about strategy is that it's the long-term direction of a company. Where do we want to be the overall leader in this industry? Do we want to be have the highest margins? Do we want to be in the most cities? What is our ultimate goal, overall goal of the organization? And what are we going to do to get there? And so the decisions you make as to how you achieve those goals, those are your tactics. Your mid-level managers are usually the ones in charge of that. And your operational decisions, that's everything day to day. So from scheduling to how much to order, those are your operational decisions. Typically, there's depending on the textbooks you read, there's somewhere between 4 and 7 steps of decision making. And this textbook has 5, but they all follow, whether they break these into multiple parts or not, they all follow this general path. Identify and define the problem. I can't make a decision until I know what exactly it is that is wrong or that can be improved. How are we going to determine if we have multiple options? How are we going to evaluate those options? Then figure out what all of our options are. If you see this term alternatives, it just means there's not a primary and then an alternative. That's probably the way you might be thinking of it. If you haven't taken a class that uses that term, you think of the main solution and alternative solution. Alternatives are just a list of all of the possible solutions, not categorizing one as better right off the bat by saying, okay, this is our choice, here's our alternative choice, which is the way you might think of it outside of this. So your alternatives are all the possible choices you could make. Then evaluate them. And then the last step of decision making is to make the decision. You have to choose which alternative you're going to use. And again, alternative is just option. Which option? Choose the option. What kind of approaches might you take to making decisions? Well, that first one, tradition, right? This is what we typically do, so we're going to just keep doing that. We tend to do this, we keep doing that, right? That's human nature. Intuition. I have a hunch, or all my experience in this industry leads me to believe that I think it's going to be busy on a Saturday, or I think that this is going to be a hit. This has the makings of being a hit product, and we should ramp up production. Rules of thumb, just using common sense ideas as to making a decision. And then finally, taking in all the relevant data and analyzing it, and thinking, well, could we make a better decision if we were able to transform that data to help us as an organization. So what is business analytics? Well, I'm glad you asked. Business analytics is that process of taking data, which is useless, and transforming it into information. So once you take numbers don't mean anything on their own. They only mean something when you compare them to something else, or when you have looked into the meaning behind them. And so once you transform that data, now you have information, or insight, as it's called here. Now that helps you make better decisions. So if any decision making is data driven, okay, we need to know maybe how many we expect to sell, what volume we expect to sell, so that we can meet the demand by producing that amount of the good, right? We have seen that we are busier at these times of days, so we need to move our schedule around to those times to make sure we meet it, right? So anything data driven, we can make an objective decision making. Objective decision making is good as a manager because you have something to fall back on. When you're answering your shareholders and your CEO as to why you did this and it failed, well, everything we had supported this idea. Yes, that's not a guarantee it would have worked. In this case, it didn't work. However, we feel that, based on the trends, based on XYZ, these numbers, these hard pieces of data, we made the best decision with the information we had available versus, I really thought it was going to work and it didn't. And we lost a lot of money, right? So it's good for you as far as covering yourself in terms of that, when, somebody's making a decision on what to do after you made a decision that didn't pan out. Tools. What tools can you use? Well, you can create insights. Again, they're using the term insights for information, but creating insights from data, that's a tool you can use. You can make better decisions by accurately forecasting. So if you can get your forecast more accurate, and you can do that in a number of ways. One of the ways is you can take past data, run it through, maybe take data from like 5, 4, and 3 years ago, and see how well that model you've built would have predicted, your 2 years ago actuals, and then see how far off your forecast was from the actuals, right? So you look at your forecast that your model would have produced in the past, compare that to the actuals from the past to see how accurate your forecasting model is, and the better you can get that model, hopefully the better, more informed decisions you can make in the future. Quantifying risk. So what's the likelihood of success? The probability that of success or failure, or of these outcomes. Making decisions under risk means that there are probabilistic outcomes, and quantifying what those probabilities are. And then just being able to come up with more, because quantity isn't defining a characteristic of better, but just better options. Analyzing the data, using optimization models to come up with possibilities that could be better than just our educated guesses, which don't discount educated guesses, right? Human capital is very important for that reason. Using someone's knowledge and experience to make decisions, you can get pretty far on that a lot of times. All right, so now we're going to categorize types of analytics, okay? And the 3 main types are going to be descriptive, predictive, and prescriptive. So descriptive means you're describing what happened. So if you wanted to know, if you wanted to print a report on something, you're describing what happened, okay? If you wanted to visualize, your sales in various regions, and you made a big dashboard to show all that off, that's descriptive. Anytime you're pulling large amounts of data and you're just looking at it, right, to look at the past, how well did we do? Are there areas we could have improved? You're describing what the data is telling us. They've added data query in here, but if you are pulling stuff from a database, you use a certain language for that. Maybe often it'll be SQL, SQL, and you'll write exactly the command to get exactly certain information formatted in a certain way. So that's That's lumped in here, so I'll just go ahead and talk about that. And then data dashboards, which was the term they used here. This is going to be your visualizations that are often interactive. Maybe you can drill down. Sometimes you'll see like if you sell all over the country a product, you could see where you're selling the best, and you could drill down all the way into counties or cities as far as sales go. Or it could just be time series. It could just be what we sold in quarter 1, 2, 3, and 4, or any kind of visualization. So often not just a single chart, right? The dashboard is usually pulling all the data here and then visualizing multiple different ways, where usually you can uncheck something on a little button and then take away this region because you really only want to compare these two or whatever. But it's that collection of all the tables, charts, maps, etc. So that's a dashboard. Tableau is one of the most popular ones when it comes to creating data dashboards. Power BI is another one. Tableau has been around for a lot longer, so that's kind of like the legacy system. It costs a lot of money, and people are hesitant to switch to Power BI, even though it's cheaper and it interacts better with Microsoft Office Suite. But there's that. I'm not going to call it sunk cost, right? Tableau is a great system, so it's not a sunk cost. But if you've already invested that much into Tableau and you've trained everybody on Tableau, you're not going to switch to Power BI. But I've noticed a lot of newer places will start up with Power BI now. But anyway, that's two different data visualization software tools. Okay, so that's descriptive, describing the data in various ways. Predictive is your forecasting. So various ways you can forecast. If you've taken operations management or quantitative methods, if you've taken it with me, you know that we talk about forecasting a lot. We learned it early on in the semester, and then it's called back to in just about every chapter. But you've got to make decisions, and if you can help predict those decisions based on how things happened in the past, and if we can reliably, look at the variance in our predictions versus what actually happened, maybe we can make a better decision because we can say, oh, there's a trend going on, or there's some sort of seasonal demand wave, or some kind of cyclical demand going on there. So making better decisions through predicting the future. You can use linear regression models, which is going to be like a huge chapter later on. We're going to take several weeks on that module when we get back from after the first exam. We get into regression. Time series analysis, that just means laying out everything, maybe quarter 1, quarter 2, quarter 3, quarter 4 last year, or 10 years ago, and then the next 4 quarters, and then looking for trends or establishing anything that way. Data mining, so this is like looking for patterns, relationships. Let's say that you had a grocery store and you're trying to lay out the way that you set up your grocery store. Well, maybe if people buy this item, they often also buy this item, and you can see those items matched up a lot. Or if you look at specific, maybe you've got a sale on potato chips, and you're thinking which one sells the most, so you're gonna set them by the sale item on potato chips next to maybe the beer or soft drinks next to the chips, so that people, even though they're getting the discount or the sale on the potato chips, they're getting that other item and they're buying it at the same time. And then simulation would be a way to see the likelihood of a decision you make by setting up a model that will show you the outcomes. And you run the simulation several times to see what you end up with, what percentage of the time, and that helps to kind of find that likelihood or probability of the success in a decision, or probability of how much revenue you can expect or profits to expect. A bank might use a simulation to help set interest rates and assess the likelihood of risk, or somebody defaulting on a loan, for example. Prescriptive analytics will also include the optimization model. So optimization is when you, sorry, that was a predictive. Prescriptive is just deciding what that best course is. So you're prescribing this because of this. So some of the things we're going to be doing are making optimization models in future chapters. So we're going to say that basically, if I had this much money to invest, based on investment rate of returns, we should allocate this much money here, here, and here. That's a portfolio model. Supply network. So it could be where I ship something from here to here to here, because that's the cheapest cost, or it gets it to the customers the fastest, or it could be a decision on when to mark down prices on goods. When do you, how long do you keep something on the shelf at, MSRP before you start discounting it to get rid of it for some other item? So those are all prescriptive. I'm prescribing this to you. You should do this based on this simulation, this optimization model that I have used. Decision analysis. This is a way to, when you have several different options. So simulation is, if I do this, this will probably happen. But decision analysis is the process of looking at all of those various alternatives. And now let's talk about the 4 V's of data: volume, velocity, variety, veracity. Don't worry, there will be an infographic about this to help show what these mean. But big data is the term that's been around for a while, referring to the fact that it's so much data you could not reasonably keep it on like an Excel sheet, right? It's something that has to be housed in a larger software that could hold larger amounts of data. This is where you get into like data warehouses and servers that host some, Access would be like the most commonly available one, because it's included with the Microsoft Office suite. But there are several other ones that one might use as far as like holding onto large amounts of data. But basically, you couldn't reasonably use it on like a home server. It's that much data, right? And so if you have all that data, well, how are we going to get to it? And so we evaluate our decisions as far as, how we're going to store that data, process that data, and access that data based on these 4 V's. So the people that are processing that data and analyzing the data, often those people will be called data scientists. Data scientists would be typically, not always, but typically would be like a data analyst that had more of a computer science background versus statistical background. That might be a easy way of saying it, fairly accurate way of saying it. So here's that visualization. Volume is just how that's your data just sitting there. How much volume, how much data is there in terabytes or exabytes of data, right? We don't even measure in gigabytes anymore, right? You've got your home computer probably has a terabyte of internal storage now, right? So how much data does it store? How much do we have available? Velocity is the speed at which that data can transfer. So if you're streaming data, your internet broadband speeds, right? That's the velocity of data. If you have, I don't know, Cox Gigablast, you've got 1 gig down, but then 30 meg up. For some reason, they cap your upstream of data at a very low amount. I guess maybe to stop people from, ripping movies and uploading them. I don't know why that's capped so low, but it is. Whereas if you have like AT&T fiber, you have close to 1 gig down and up. Theoretically, it still depends on the infrastructure, your modem, and how many people are using it, accessing that hub nearby. But usually, from what I've seen, above 900 AT&T, both up and down, which is pretty good. Variety. So this is how many different types of data. They've got text and multimedia listed here. I'll tell you a boring story real quick. I used to work for Sprint tech support back in 2003, and Sprint had just purchased Nextel, which was the like push to talk phones that people would use like walkie-talkies on like construction sites. And they had just started doing MMS messaging, multimedia messaging, meaning you could send pictures through a text message. That was crazy, right? That was 20 years ago, and you could send a picture through a text message, because the text message and SMS can only send so much. I forget the exact amount of size, but it's a very small amount, and that's why if you have an iPhone and you have iMessaging, you can send these videos that have full display. But if you get into a group message and some people are on Android and some people are on iPhone, or you've got the problem where the Android proprietary messaging system doesn't interact with the iPhone proprietary messaging system. So everyone's sending as, MMS messages, and the video quality is like, you don't even want to use it, right? So you send them a Google Photos link instead or something, right? Anyway, variety, right? So those are different types of messaging. Some require more data, some require less data. So sending a simple text, fine, you can do that. But when you're trying to send multiple types of data, video, pictures, whatever, you send too many pictures at once, it'll just error out when you send those texts, and it's not sending through a proprietary messaging system that uses data instead of those old outdated cellular SMS or MMS ways. And then veracity is, we'll call it the truthiness of data. Are you getting the whole picture of it? Are there missing fields? Is the file corrupted? Is there too much ambiguity because people are entering, different letters as acronyms for something? So now it's like, okay, well, you're using this term, using this term, using this format. Oh, I miskeyed this. Well, this is saying 98 degrees, 97 degrees, 96 degrees, 950 degrees. Okay, that's probably 95 degrees, but you accidentally hit the zero at the end. But there's uncertainty of that data. And so that's the veracity. How much can I trust the data as written? And do I need to clean that up and investigate that? And then the last thing, I'm just going to jump to the data security. So if you have large amounts of data, you have to make sure that it's accessible by people who are authorized to access it, the right amount of encryption, and to make sure that it can't be accidentally deleted, or that you have redundancies to make sure that's stored in multiple places in case you lose access to it. There's big data. All right. Now, analytics in practice. We're going to talk about some of the various industries that use analytics. Business analytics is kind of the broad term for analyst jobs in various industries. So your business analytics go from, on the far left here, I think that I can put a laser pointer on it. There we go. So from the far left here, standard reporting, not very complex, right? Your degree of complexity along your x-axis here. Standard reporting, not very complex. Using optimization or simulation models, fairly complex. And then how much competitive advantage do you get by using them? Standard reporting, well, everyone's doing the same reports. They probably have access to the same reports. Everyone can, pull data from their own databases. Everyone can make a visualization. You can make a simple chart in Excel in a few seconds, right? So you're not gaining a lot of edge for that. And the degree of complexity, relatively speaking, is not that high. As you get more complex, typically that means you're going to gain more of an advantage. And so if that was the case, if you had people who could do more complex stuff and it got you more of an advantage, you would be willing to pay more money to have that done. And that's where the analyst comes in, or the data scientist comes in, because you're doing the more complex stuff. You're actually prescribing what people do, and you're probably accountable for those decisions in some manner. But that's why it's that skill level requirement is why the job pays well, and why they're it's so in demand. Predictive and prescriptive are sometimes referred to as advanced analytics because, again, the degree of complexity is higher for these than it is for just describing the data, making visualizations, querying data. Financial analytics. So we're just going to kind of speed run through the types of jobs that we use analytics. But a financial analyst would try to forecast performance of financial investments, assess various risks involved with investing or loaning money. A lot of simulations using to simulate the possible market in the financial sector based on past performances and waves we've seen over time. HR analytics. So you want to hire the best person for the job. Maybe you take these you've seen who's worked out in the past, and you see, well, what specific skills that we need somebody to have to do that. But another, I don't see it listed here, but one way I've seen analytics used in HR is looking at employee satisfaction survey scores and looking for specific indicators that indicate the likelihood of turnover. And that helps you kind of assess what you need to do differently to make sure you retain employees and that you are prepared to hire employees because it looks like somebody's probably going to leave soon. Achieving diversity goals. So if you want to ensure that you are not hiring people based on race, and that your workforce represents the diversity of the country, of the region in which you live, and that you're not making decisions that show any kind of bias when it comes to diversity. Marketing analytics. So this is using all the data about the customer to sell stuff to them more effectively, to get them to buy stuff maybe they didn't know they wanted or needed, use their advertising budgets better, forecast demand better. So marketing isn't all marketing sometimes gets lumped in with advertising, but that's not necessarily the same thing. Setting the price of an item is marketing, to see what is the right price point to sell and get the margins that are desired. What product lines should we be selling? What should we be producing? What can we do to increase customer satisfaction? That's within the scope of marketing. It doesn't necessarily mean making advertisements, right? Some trends for marketing analytics. That's interesting because there's not a scale on this side. This graphic, we don't know what these mean. These could be, what does this mean? I'm taking this slide out for next time. Sorry, guys, because there's, this is a bad graphic. We don't know. This is a trend. We can see that marketing analytics, as far as these three jobs, is going much at a higher rate. But like, what is the y-axis here? All right. Sorry, I didn't notice that. I would have taken this slide out. Healthcare analytics, so patient scheduling, as far as capacity for at different times, purchasing of equipment, controlling inventory, to some degree, diagnosis and treatment. This has been working. This has been working the most. When people show these specific symptoms, it's more likely than not that this is the treatment, or that you have this ailment, right? Supply chain analytics, sorting of goods, getting it to the right place on time, more efficient delivery. Analytics within the government to drive out inefficiencies. We need more analysts within the government because we are I think nobody's on budget, right? So a lot of inefficiencies. We've got the Department of Redundancy department. Some of you will get that. Analytics for nonprofits to ensure effectiveness and accountability. If you're donating and you have clients at a nonprofit, are you using those donations effectively. Sports analytics, there's a fun one. You can use that to draw up plays to determine the likelihood of future performance success of a player you're about to draft. How much should you offer in a contract? When to switch pitchers? Interesting. Adjust ticket prices. Too high. Plus, football is better it's just better on TV. Sorry, you go to a football game, you end up watching the big jumbotron anyway because you can't see the players. Basketball is better live. Baseball is better live. Hockey is better live, but football much better on TV. All right, and then finally, web analytics. So when you're creating a website or social media, analyzing that activity in order to maybe put the right ads on the right streams, or which one to use to promote, between Facebook or TikTok or wherever else, where should you be advertising? But then also taking those analytics you get from that and using them in other industries. All right, that is chapter 1. Use this information along with the readings from your book to take your chapter 1 quiz. Thanks, everybody. We will see you in the next module.